Hello, in this lecture we'll find out the value of angle x. In the drawing we have triangle ABC. We know that this is angle ABC. This is equals to 15 units in its size. This is angle ACB. This is equals to 30 units in its size. We also know that BP equals to PC. And our task is to find out the size of this angle APC is equals to x. We have to find out the value of this angle x. So first of all, it is given us a question that BP equals to PC. So if we define the length of BP as A, then the length of PC must also equal to A because they are equal to each other according to what is given us the question. So BP equals to A according to our definition, and therefore PC must also equal to A because they are equal to each other. So in the next step, we will do a construction. That is to say, we'll extend, first of all, we'll extend side CA of this side ABC by a straight line. And then from point B, we create angle of 15 degrees with AB. Repeat again. From point B, we draw a straight line that creates angle of 15 degrees in this side AB. So actually, this angle equals to 15 degrees in its side according to our construction. And we'll extend the leg of this angle by a straight line until it touches the extended side CA. And we define the touching point of the extended side CA with this extended leg of this angle. This point is point M. By doing this construction, we create a triangle BMC. Triangle BMC is an isosceles triangle. Why? Because those two angles, they are both equal to 30 degrees. So, write it down. The big triangle BMC is an isosceles triangle. Those two angles are equal to each other. Each of them is equal to 30 degrees. So, write it down. This is the big triangle BMC. That is an isosceles triangle. And therefore, we can implement here rule 20 on the isosceles triangle BMC. So, repeat quickly on rule 20. According to rule 20, the perpendicular to the base of an isosceles triangle bisect the base. In the drawing, we have triangle ABC, that is an isosceles triangle, because AB equals to AC, or those two angles are also equal to each other. So BC is the base of triangle ABC, the isosceles triangle ABC. According to this rule 20, the perpendicular AD to the base BC bisect the base BC. So from point A, we draw perpendicular to the base BC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to our construction. And according to rule 20, the perpendicular AD bisects the base BC. That is to say, the perpendicular AD divides the base BC into two halves. The first half is BD, the second half is DC, and each half equals to BC over 2. So AD equals to DC equals to BC over 2. So we can actually implement rule 20 in our drawing. Well, because in our domain we have the associated triangle BMC. Those triangles are equal to each other there, and therefore triangle BMC is an associated triangle. The base of the associated triangle BMC is BC. According to Rule 20, the perpendicular from point M to the base BC bisects the base BC. That is to say, divide the base BC into two halves. So the perpendicular from point M to the base BC must touch the base BC at its midpoint. So, and the midpoint of the base BC is here at point P. Why point P is the midpoint of BC, the base BC? Because of the fact that at point P the base BC is bisected into two halves. The first half is VP, the second half is PC. Each half equals to each other. VP equals to PC. So the perpendicular from point M to the base BC will touch the base BC at its midpoint. That is to say, at point P. So actually, this angle equals to 90 degrees in its size, and this angle also equals to 90 degrees in its size according to our construction. Why? Because from point M, from the vertex M of triangle NBC, we go perpendicular to the base BC. Therefore, those two angles are equal to 90 degrees in their sizes according to our construction. Because again, the perpendicular from point M to the base BC must touch the base BC at point P, that is the midpoint of the base BC. Okay, so here we focus on this right triangle, triangle MPC. The right triangle MPC sinus 30 degrees, sinus 40 degrees equals to MP over the hypotenuse MC. And again, in the right triangle MPC, sinus 40 degrees equals to MP over MC. MC is the hypotenuse of this right triangle MPC, so we will define the hypotenuse MC as 2B. MC equals to, the hypotenuse MC equals to 2B units in itself according to our definition. So here we substitute MC by 2B. So sinus 40 degrees equals to MP over MC is 2B. So total, we found out that sinus 40 degrees equals to MP over 2B. Here we multiply this equation by 2B and we get that 2B times sinus 40 degrees equals to MP. Sinus 40 degrees is 1/2, so we substitute sinus 40 degrees by 1/2, and we get that 2B over 2 equals to MP. 2B over 2 is B, so B equals to MP. B equals to MP units in its length. Or MP equals to B units in its length. This is the perpendicular to the base BC, the associated triangle BC. The perpendicular to the base BC, MP equals to B units in itself, according to what we have already found out just like now. So MP equals to B units in its length. So in total we found out that if MC equals to 2B, then MP equals to B. Okay. So in the next step we will focus on the big triangle MBC. This big triangle MBC, AB is the angle bisector of this angle MBC. Again, the big triangle MBC, AB is the angle bisector of this angle MBC. That is to say, divides angle MBC into two halves. Each half equals to 15 degrees in size. And therefore, we can implement here Rule 19. Rule 19 is about angle bisector theorem. Actually, angle bisector theorem has two directions. We use both directions of angle bisector theorem. The first direction is Rule 19. According to Rule 19, this is triangle ABC. In this triangle ABC, if we know that AD is the angle bisector of this angle BAC, then the following relationship exists between the sides of this triangle ABC. So if AD is the angle bisector of angle BAC, then BD over DC equals to AB over AC. Again, BC times DC equals to AB over AC. Actually, this is the first direction of angle bisector theorem. Angle bisector theorem have another direction. The other direction of angle bisector theorem is actually Rule 21. Rule 21 is the converse rule of Rule 19. That is to say, according to Rule 19, if you know that AD is the angle bisector of triangle ABC, then the following relationship exists between their sides. BD over DC equals to BA over CA. And the converse rule of this Rule 19 is says that if the following relationship exists between the sides of this triangle ABC, that is to say, if you know that BD or DC equals to AB or AC, then we conclude that AD is the angle bisector of triangle ABC. So we have here angle bisector theorem works on both directions. The first direction is that if we know that AD is the angle bisector of this triangle ABC, then the following relationship exists between the sides of triangle ABC. BD over DC equals to AB over AC. And the converse rule of this Rule 19 is, if we know that the following relationship exists between the angles of this triangle ABC, that is to say, if we know that BD over DC equals to AB over AC, then we know we conclude from it that AD is the angle bisector of this triangle ABC. So we have the rule of the converse angle bisector theorem is Rule 19. If we know that AD is the angle bisector of triangle ABC, then the following relationship exists between their sides. The converse rule of angle bisector theorem is that if we know that the following relationship exists between the sides of triangle ABC, then we conclude that AD is the angle bisector of triangle ABC. So, in conclusion, you can say that the angle bisector theorem works on both directions. So, first of all, we will implement Rule 19. That is the first direction of angle bisector theorem. Again, according to Rule 19, if AD is the angle bisector of angle BAC in this triangle ABC, then the following relationship exists between their sides. BD over DC equals to AB over AC. Okay, so we have already found out that we know that AB is the angle bisector of angle MBC in this triangle MBC. Again, AB is the angle bisector of angle MBC in this big triangle, triangle MBC. So we can implement here rule 19. So write down AB is the angle bisector of angle MBC in the big triangle, triangle MBC. And because of the fact that AB is the angle bisector of angle MBC, triangle MBC, you can implement rule 19. According to rule 19, the following relationship exists between the sides of this triangle, triangle MBC, the big triangle, triangle MBC. MB, but MB over BC, MB over BC, MB over BC equals to MA over AC. Okay, again, this triangle MBC, AB is the angle bisector of this angle MBC. Therefore, according to rule 19, the following relationship exists between the sides of this big triangle, triangle MBC. MB over BC equals to MA over AC. So according to rule 19, triangle MBC, MB over BC equals to AM over AC. We already found out that according to our definition, MC equals to 2B, and we already found out that MP equals to B. So we have MB over BC. MB is 2B. BC in total equals to A plus A, that is 2A. So MB over BC is 2B over 2A, and it equals to MA over AC, equals to MA over AC. MA over AC. So here we divide this side of the equation by 2, so 2 will get cancelled. So in this side of the equation we left only with B over A equals to MA over AC. And again, in total we should found out that B over A equals to MA over AC. So in this triangle MCP, B over A equals to MA over AC. Again, this triangle, so the green triangle MPC, this green triangle MPC, and we found out that B over A equals to MA over AC. So now we will implement the inverse rule of angle bisector theorem. According to inverse rule of angle bisector theorem, if the following relationship exists between the sides of this triangle MBC, then AP is the angle bisector of this triangle MPC. And because of the fact that B over A equals to MA over AC, it means that AP is the angle bisector of the green triangle MPC. according to Rule 21. So please click on Rule 21. According to Rule 21, if BD over this, in this triangle ABC, if BD over DC equals to BA over AC, then AD is the angle bisector of this triangle ABC. Repeat again. It is the inverse rule of the angle bisector theorem. Now we know that the following relationship exists between the sides of this triangle ABC. That is to say, we know that BD over DC equals to AB over AC, and therefore we conclude from the fact that the following relationship exists between the sides of this triangle ABC, that AD is the angle bisector of this triangle ABC. Okay, again. So Rule 21 is the inverse rule of Rule 19. In Rule 19, we know that AD is the angle bisector of triangle ABC, and therefore BD over DC equals to AB over CA. Here we know that the following relationship exists between the sides of this triangle ABC, that is to say BD over DC equals to BA over AC, and therefore from the fact that the following relationship exists between the sides of this triangle ABC, we will conclude that AD is the angle bisector of triangle ABC. So it is the inverse rule of Rule 19. Likewise, we can implement Rule 21 in our drawing, because of the fact that in this green triangle MPC, we know that B over A equals to MA over AC. We conclude from the fact that the sides of this green triangle MPC are proportional, that AP is the angle bisector of this green triangle MPC. So according to Rule 21, it is the inverse rule of Rule 19. According to Rule 21, from the fact that the sides of this green triangle MPC are proportional, we will conclude that AB is the angle bisector of this triangle MBC. AP is the angle bisector. It is the angle bisector in triangle MBC, but actually AP bisects angle MPC. So AP, according to Rule 21, AP is the angle bisector of this angle MPC. So AP is the angle bisector of angle MPC. But according to Rule 20, the perpendicular from the base of this isosceles triangle MBC bisects the base BC. That is to say, this is a right angle, this is also a right angle. So AP bisects angle APC, that is equals to 90 degrees in its size. So AP bisects the angle, it is the angle bisector of MPC. That is to say, it bisects this angle, that is a right angle. It bisects angle MPC, that is 90 degrees in its size according to Rule 20. So if AP bisects this angle, that is a right angle, it means that each half must be equal to 45 degrees in its size. So the first half is angle MPA, that is 45 degrees. And the second half of the big angle MPC is also 45 degrees in its size. That is to say, we should find out that the angle that we are looking for in this question, that is angle APC is equal to x, is equal to 45 degrees in its size. So the missing angle APC, that is the angle that we are looking for in this question, that is equal to x, to angle x, is equal to 45 degrees in its size. That is the answer to the question. Repeat again. The size of this angle APC is equal to x, is equal to 45 degrees in its size. So In the next step, let's have the lecture. Our task in this lecture is to find out the size of this angle APC that equals to angle X. We have to find out the value of this angle, angle X. So, in the drawing, we have the big triangle ABC. We know that BP equals to PC. We also know that this is angle ACP that equals to 30 degrees inside. This is angle ABC that equals to 15 degrees inside. Again, our test was to find out the size of this angle, angle X, is equals to APC. So first of all, we know that BP equals to PC. So if we define BP side, then PC must be also equal to A because they are equal to each other. So again, because of the fact that BP equals to PC, then if BP equals to A, then PC must be also equal to A. In the next step, we did a construction, that is to say, we extended this side CA of triangle ABC by a straight line, and then at this point P, we created angle that equals to 15 degrees inside. So the leg of this angle that is equals to 15 degrees inside, this is the leg BM. So it creates 50 degrees if the leg AB. So we created angle of 50 degrees with side AB. The first leg of this angle is AB and the second leg is BM. So we draw this straight line BM in such a way that it will get 50 degrees with this leg AB. So this angle equals to 15 degrees inside according to our construction. We extended the leg BM, we extended this leg of this triangle that equals to 15 degrees inside in its leg by a straight line until it touches the extended side CA. And we define the extended side CA with the touching point of the extended side CA with the extended leg B, with this extended leg. This point is point M. So by doing this construction, we created the big triangle, triangle BMC. In the big triangle BMC, those two angles are both equal to 30 degrees in their sizes, therefore this is an isosceles triangle. And BC is the base of this isosceles triangle of triangle ABC. Again, BC is the base of the isosceles triangle, triangle ABC. And here we can implement rule 20 in our drawing. According to, so a bit quicker on rule 20. According to rule 20, the perpendicular to the base of an isosceles triangle bisect the base. In the drawing, we have triangle ABC that is an isosceles triangle because those two sides are equal to each other and those two angles are also equal to each other. And from point A, we draw perpendicular to the base BC. So this angle equals to 90 degrees and this angle also equals to 90 degrees inside according to our construction. And we define the touching point of the perpendicular from point A and the base BC. This point is point D. According to this rule 20, the perpendicular to the base BC, the perpendicular AD bisect the base BC. That is to say, AD bisects the base BC into two halves. The first half is BD, the second half is DC, and each half must be, of course, equals to BC over 2. So BD equals to DC equals to BC over 2. So we can implement rule 20 in our drawing. One put in our drawing, we have the isosceles triangle BMC. From point M, from the vertex M, we go perpendicular to the base BC. According to rule 20, the perpendicular to the base of an isosceles triangle bisect the base. First of all, when you draw a perpendicular, if this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. But the question is, well, the perpendicular from point M will touch the base BC. The perpendicular from point M must touch the base BC at its midpoint. Why? Because according to Rule 20, the perpendicular to the base of an isosceles triangle bisects the base. If it bisects by the base, it means that it must touch the base BC at point P, that is the midpoint of the base BC. Why point P is the midpoint of the base BC? Because BP equals to PC. So the first half of the base BC is BP, the second half is PC, and therefore point P is the midpoint of this base BC. Therefore the perpendicular from point M that bisects the base BC must touch the base BC at point P, that is the midpoint of BC. So actually this angle equals to 90 degrees in size, this angle also equals to 90 degrees in size according to our construction. Actually I had a mistake in the angle itself. It doesn't look as a right angle, but it should be a right angle. Those figures must be both right angles. The problem is the drawing. So, repeat again, the perpendicular MP bisects the base BC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the construction. And the perpendicular from point M touch the base BC at point P, that is the midpoint of the base BC. So this is a right angle. This is a right angle, therefore triangle MPC is a right angle. This right angle MPC, sin 30 degrees, equals to MP over this right angle MPC, sin 30 degrees, equals to MP over the hypotenuse MC. And again, this right angle MPC sin 30 degrees equals to MP over MC. MP is the missing side, so we have this. We have the hypotenuse MC. We define the length of the hypotenuse MC as 2b. So substitute the hypotenuse MC by 2b. So in total, we found out that sin 30 degrees equals to MP over 2b. We multiply this equation by 2b and finally found out that MP equals to 2b times sin 30 degrees. Sin 30 degrees is 1/2, so in total this expression equals to 2b times 2b over 2. 2b over 2 equals to MP. 2b over 2 is b. So in total we found out that the perpendicular MP to the base BC equals to b units in itself. So in total, we found out that if the hypotenuse MC equals to 2b, then the perpendicular MP must be equal to b. Okay. So from the drawing, it is very easy to see that if you focus on the big triangle MBC, that AB is the angle bisector of this angle MBC. Again, AB is the angle bisector of angle MBC because it bisects angle MBC into two halves. Each half equals to 15 degrees in size. Okay. And again, AB is the perpendicular of the big angle MBC, entire MBC. And therefore, we can implement here Rule 19. It is the first direction of angle bisector theorem. Repeat again that angle bisector theorem works on both directions. So we implement the first direction of angle bisector theorem, this big triangle MBC. So repeat quickly on Rule 19. This is the first direction of angle bisector theorem. Turn it to angle bisector theorem. This is triangle ABC. And if we know that AD is the angle bisector of this angle BAC, then the following relationship exists between the sides of this triangle ABC. BD over DC equals to AB over AC. Again, BD over DC equals to AB over AC. So if you know that AD is the angle bisector, then AB then BD over DC equals to AB over AC. So this is the first direction of angle bisector theorem. So we can implement the first direction of angle bisector theorem in our drawing. Well, because in our drawing, if you focus on the big triangle MBC, we know that AB is the angle bisector of angle MBC. It bisects angle MBC into two halves. Each half equals to 15 degrees in size. Therefore, we can implement here rule 19. According to rule 19, MB over BC equals to MA over AC. Again, according to rule 19, MB over BC equals to MA over AC. Because of the fact that AB is the angle bisector of angle MBC, the big triangle MBC, then according to rule 19, MB over BC equals to AM over AC, or MA over AC. We have already found out that actually MB equals to 2B according to our definition. Okay, again, this is side MB is equals to 2B units in itself according to our definition. And we actually found out that if MB equals to 2B, then MP equals to B. Okay, so according to rule 19, we found out that MB over BC equals to MA over AC. MB is 2B over BC. BC is A plus A, that is 2A. So MB over BC is 2B over 2A. So 2 will get cancelled and we left only with B over A equals to AM over AC. And again, B over A equals to AM over AC. Now note that B over A equals to AM over AC. Now, if we focus on the green triangle MPC, we actually found out that B over A equals to MA over AC. That is to say, we have here the sides of this triangle, the green triangle MPC are proportional, and therefore, according to rule 21, that is the opposite direction of angle bisector theorem, AP must be the angle bisector of angle MPC. Again, because of the fact that this again triangle its sides are proportional, then AP must be the angle bisector of this green triangle MPC. AP is the angle bisector of this angle MPC. So, if we quickly on rule 21, that is the opposite direction of rule 19. According to rule 21, this is triangle ABC. So if we know that the sides of this triangle ABC are proportional, that is to say, we know that BD or DC equals to AB over AC, then we add from the fact that the sides of this triangle ABC are proportional, that AD is the angle bisector of this triangle ABC. That is to say, AD bisects angle BAC into two halves. Okay, the opposite direction of rule 19. In rule 19, we know that AD is the angle bisector, and therefore the following relationship exists between their sides. Here we know that the following relationship exists between their sides, and therefore AD is the angle bisector. So, we have rule 19 and rule 21, that is the opposite rule of rule 19. So we know that BD over DC equals to AB over AC, and therefore, from the fact that the sides of this triangle ABC are proportional, we derive from it that AD is the angle bisector of angle BAC. So we can implement rule 21 in the green triangle MPC. Therefore, we found out that the green triangle MPC, the sides of the triangle right triangle, the sides of the green triangle MPC are proportional. That is to say, we should know that B over A equals to MA over AC. Again, the sides of the green triangle MPC are proportional because of the fact that B over A equals to MA over AC. Okay, found out that B over A equals to MA over AC. Again, we just found out that the green triangle MBC, B over A equals to MA over AC. That is to say, the sides of this green triangle MPC are proportional, and therefore we derive from it that AP is the angle bisector of angle MPC. Again, from the fact that the sides of this green triangle MPC are proportional, we derive that AP is the angle bisector of angle MPC. It is the opposite rule of rule 19. From rule 21, AP is the angle bisector of angle MPC. AP is the angle bisector of the big angle MPC. This triangle, the green triangle MPC. But we already found out that angle MPC is a right angle. AP is the angle bisector of the right angle. So each angle must be equal to 45 degrees in size. This is the first half of the right angle, that is 45 degrees. Angle MPC equals to 45 degrees. The second half, that I'm showing angle X, that is the angle that you're looking for. Angle APC is equal to angle X is equal to 45 degrees in size. So in total, we found out that the missing angle that we are looking for in this question, that is angle APC, is equal to angle X is equal to 45 degrees in size. Okay, thank you very much.